All right, buckle up, everybody, because today we're diving headfirst into one of the most talked about papers in AI history. Attention is all you need.
A bold title, wouldn't you say? And for good reason. This paper, from a team of researchers at Google back in 2017, didn't just introduce a new model. It sent shockwaves through the world of natural language processing.
Totally. I mean, this paper is practically legendary now, but let's be honest, it's not exactly what you'd call a light read. That's where we come in. We're here to break down the core concepts of the transformer model, the what, the why, and the wow, so you can walk away feeling like you've had a serious aha moment.
Absolutely. And to truly appreciate the elegance of the transformer, it's helpful to start with the problem it was designed to solve.
Okay, so paint us a picture. What were the limitations of the old school approaches to language processing?
Well, imagine trying to understand a sentence, but you're forced to read it one word at a time. And here's the kicker. With each new word, the previous one starts to fade from memory.
Ouch. That sounds frustrating. Like trying to remember a phone number by repeating just one digit at a time. Not very efficient.
Exactly. And that, in a nutshell, is how traditional recurrent neural networks, or RNNs, used to tackle language. They processed information sequentially, which led to some pretty significant roadblocks.
Roadblocks like what? Give us the technical nitty-gritty.
One major hurdle was something called the vanishing gradient problem. Basically, as RNNs move through a sentence word by word, the signal that helps them learn what we call the gradient can become weaker and weaker, especially over long sequences. It's like trying to tell a really long, rambling story. The details from the beginning might get a little fuzzy by the time you reach the end.
So not only are these RNNs slow, they literally start forgetting crucial information along the way. No wonder they struggled with things like capturing the meaning of complex sentences or translating longer texts accurately.
Precisely. And this is where the attention is all you need. Paper swoops in with its groundbreaking solution, the transformer. Instead of this tedious word-by-word processing, the transformer can look at an entire sentence simultaneously, weighing the relationships between all the words at once.
Hold on, so it's like the difference between trying to understand a painting by obsessing over each individual brushstroke versus stepping back and taking in the entire canvas at once.
That's a fantastic analogy, and its ability to grasp the whole picture is precisely what gives the transformer its edge.
Okay, now things are getting interesting. So how does this seeing the whole picture actually translate into better results? We'll uncover that and more right after this quick break. Don't go anywhere. So the transformer can see the forest for the trees. But how does that translate to actual improvements? Give us the details.
Well, for one, because the transformer processes everything simultaneously, it's way faster to train. Imagine reading a novel, but instead of page by page, you could instantly absorb the entire thing.
Okay, speed makes sense. But what about the accuracy? The paper had some pretty impressive claims about how much better the transformer performed.
Oh, they did, and the results speak for themselves. For instance, Table 2 in the paper shows just how much the transformer dominates in machine translation tasks compared to the older models. And keep in mind, this was just the first version.
Just a glimpse of its potential. Let's dive into the specifics. What's under the hood of the transformer that makes it so revolutionary?
At its core, it's this concept of self-attention. It's like the model can analyze the weight of each word in relation to every other word in a sentence, no matter how near or far.
So it's like each word is having a conversation with every other word in the sentence, trying to figure out the connections.
Exactly. And it gets even cooler. The transformer doesn't have just one attention head, but multiple, hence multi-head attention.
Multiple heads. Okay, now you've got my attention. Why would it need more than one way to, well, pay attention?
Because language is incredibly nuanced. Think about it. One word can have so many different meanings depending on the context. Each head focuses on a different aspect of the input with multi-head attention.
So one might be looking at the grammar, while another analyzes the emotional tone, and yet another is trying to decode the overall meaning.
You got it. And by combining what each of these heads picks up, the transformer gets this incredibly detailed and layered understanding of the sentence.
Now that is impressive, but there's one thing I'm wondering about. If the transformer is looking at all these words at once, how does it keep track of the word order? Word order is essential for understanding meaning. Dog bites man is very different from man bites dog, right?
That's where positional encoding comes into play. The authors found a clever way to work information about word order into the model, even though it processes everything simultaneously.
Did they invent some sort of AI magic wand to pull that off?
It's almost like that. They created this ingenious system using special tokens added to each word, and these tokens act like a map of the word's position in the sentence. So even though it's processing everything at once, the model still knows that dog comes before bites, which comes before man.
It's like giving each word a little number tag so they know their place in line, a high-tech game of linguistic hopscotch.
Exactly. It seems like a small detail, but it makes a huge impact. This innovation is one of the things that allows the transformer to truly excel.
Wow, every part of this model was meticulously crafted. But the authors of this paper weren't content with simply revolutionizing machine translation, were they? It seems like they had a much larger vision for the transformer.
You hit the nail on the head. While the paper mainly focuses on how the transformer transforms translation, it also hints at it potentially being a general-purpose architecture for understanding language, and maybe even information in general. They even tested it out on something called constituency parsing, which basically breaks down a sentence's grammatical structure.
So not only can this transformer understand the meaning of a sentence, but it can also tell you how it's grammatically structured, like having a digital linguist at your beck and call. Incredible.
That's just the tip of the iceberg. The paper also teases its potential beyond text, hinting at applications in areas like image and audio processing.
Talk about thinking outside the box. It's like they've built this incredible engine for understanding language and then realized they could use it to power so much more.
Exactly. That's why this paper, Attention is All You Need, is considered groundbreaking. It wasn't just a step forward, it was the beginning of something much bigger.
It's like they handed researchers this incredible new tool and said, go wild, see what you can create. And wow, have they ever.
It really is something. Since this paper came out, the transformer has become the foundation for so many AI models and breakthroughs. You know, those crazy realistic chatbots that have everyone talking?
The ones that can write you a sonnet and then have a conversation that makes you do a double take.
Exactly. Those are powered by transformers. But it goes way beyond that. Transformers are now being used for everything from diagnosing diseases to making self-driving cars even better. They're everywhere.
It's amazing how one paper with this elegant solution to a specific problem could have such a huge ripple effect on so many different fields.
What I find most fascinating is how the core idea of the transformer, this self-attention, is being used in ways the authors probably never even dreamed of. It's like they stumbled onto this fundamental truth about information processing, understanding relationships, is key to unlocking meaning.
Kind of like how the internet changed everything. It wasn't just about sending emails quicker, but about connecting information and people in this completely new way. The internet wasn't just a tool, it sparked a whole new way of thinking and interacting with the world.
That's a great comparison. And just like the internet, we're still figuring out the full impact of the transformer. We're only just starting to explore what it can really do.
It's exciting, but also a little bit intimidating. We've been given this powerful tool thanks to this paper, but it's up to us to make sure we use it wisely and ethically.
Couldn't agree more. That's why I think this paper should be required reading for anyone who's curious about the future of AI. It's not just a technical paper, it's a call to action, a reminder that with great power comes great responsibility.
Well said. So, to all our listeners out there, if you want to really explore the incredible world of the Transformer, we encourage you to check out the full paper. You can find a link in our show notes. And as you dive in, think about this. What new possibilities can you imagine now that we have the power of attention at our fingertips? Until next time, happy exploring.